Hello everyone, here is an opportunity to win exciting prizes by our Google channel. All you have to do is watch our free videos and answer in our comment box for the questions asked in between our videos. Thank you.
Hello everyone, this is Manjushree. I teach physics concepts. In my previous video, I have explained in detail about what is pressure, how is pressure related to force and area of any of the objects. Pressure means force exerted by an object per unit area is the pressure created in that object. And by decreasing the area, we can increase the pressure, and also by increasing the area, we can decrease the pressure exerted by any of the object. That is, area is inversely proportional to pressure and force is directly proportional to pressure. That is, whatever the examples I have discussed in my previous video, I have explained about the pressure exerted by solid objects. In this video, I'll be explaining how liquid molecules or gaseous molecules exert pressure on any of the object. That is, whenever force is applied by liquid or gaseous molecules, what is the force per unit area, that is pressure created by liquid or gaseous molecules, will be explained in detail in this video. To make you understand what is the pressure exerted by liquids or gaseous molecules in detail, I'll be explaining that concept using one of the activity. That is, I have a glass of water, and whenever we measure pressure which is created by this liquid which is there inside this container, we that is liquid which is there in this container, we consider this liquid in different layers. For example, this is one of the layer, other layer, this is the bottommost layer. That is, the pressure exerted by this liquid molecules will be considered in different layers, and in each layer the density of the molecules which is present will be different. And whenever we measure the pressure exerted by this liquid, we consider the density as well as the height of this container. That is, the liquid consists of molecules, and the movement of the molecules in this liquid will be that is creating some pressure. That is, the movement means there is some action which is taking place, and that action is called force, and that force per unit area will give us pressure. And whenever we consider this liquid which is there in this container, that liquid will be exerting pressure in all the direction. That is, the molecules which is present inside this container will be exerting pressure in all the directions, and that pressure will be applied on the walls of the container. And also, I told we will consider pressure exerted by liquid in different layers, and in each layer the density is different. And whenever we consider the topmost layer, density will be less when compared to the bottommost layer. Why? Because the bottommost layer will be experiencing the force exerted by above layer, and this layer will be experiencing the force exerted by this layer. This layer will be experiencing the force exerted by the molecules which are present in this layer, and the topmost layer will be less dense. Why? Because here there won't be any other pressure exerted on this layer. There will be atmospheric pressure. That is a different concept which we will study again. So here the density of the molecules present in the top layer will be less. Therefore, the pressure exerted in the topmost layer will be less when compared to the bottommost layer. In the bottommost layer, what happens is the force, the force and the pressure which is exerted by all the molecules which is there in the upper layers will be added on to the bottommost layer. Therefore, the pressure exerted in the bottommost layer of any of the liquid container will be more when compared to other layers. Why? Because it the bottommost layer will be more dense. When density is more, the pressure exerted by that region will be more. And how is pressure exerted by fluids? Fluids means anything which flow. It is liquids as well as gaseous molecules. That is, in liquids or gaseous molecules, pressure exerted by those particles will be exerted in all the direction on the walls of the container. If this is the container, this glass is the container, and the liquid which is inside this is exerting pressure, that liquid will exert pressure in all the directions of the container, and the pressure will be exerted on the walls of the container. And here I have displayed the same thing which I have explained now, that is liquids exert pressure at any point inside the container depends on the density and height of the column above that point. That is, whenever we consider pressure exerted by liquids, we'll consider the density as well as height of the liquid column above that point which we are considering the point of reference where the pressure is exerted. And liquid pressure on the bottom of the container does not, that is bottom of the container, I told here the bottom layer will be consisting of more pressure. I told it is not because the area is more here, even though area it depends on the density. Even though pressure depends on area, here we will be considering the pressure exerted by liquid depending on the concept of density. And next, the last that is uh, explanation what I have given is, an external pressure applied on a liquid in closed container is transmitted uniformly throughout the liquid. If it is a closed area, then if I am applying some force on it, and if the pressure is created inside this container, then that pressure which is created inside this container will be transformed uniformly. That is, where if I measure force in any of the direction, that is, for example, if imagine if this is a plastic bottle, and if I take a needle, and if I press this end, then water will flow towards this hole which I have created, and if I press towards this region, even there the water will start flowing because due to the pressure created in that region. And the flow of liquid in both the regions will be same. Why? Because liq- liquids will be exerting pressure in all the direction, whether it's bottom or sidewise, the pressure created by the liquid will be same in all the direction. And it completely depends on the, that is the pressure exerted by the liquid completely depends on the density as well as the air column of the liquid which the container is containing. And in next points I have written that the deeper into a liquid you go, greater the height of liquid molecules from above, and the pressure will be higher. That is, deeper we go into any of the liquids uh, in the container, there the density will be increased when we go downwards. Therefore the pressure which is created by that region will be more when compared to the upper surfaces. And pressure depends on density of the liquid. That is what I told. More the dense, then higher will be the pressure. Therefore, what we can conclude, how are the liquids and gaseous molecules? Gaseous molecules also act in the similar way how liquid molecules behave. That is, gaseous molecules also exert pressure in all the direction, and also the pressure in gaseous molecule depends on the density. That is, in detail about atmospheric pressure I'll be explaining in my next video. In this video I have explained what is pressure and how liquids exert pressure on the container in which it is present. Thank you.